Okay, so in today's video, I'm going to be showing how you can set up a similar build with an outdoor radiator. So, our outdoor radiator is currently turned off. It has a switch, and it has a PWM controller that runs the 4 fans on the top and 4 server fans at the bottom and pushing upwards. The loop still circulates through the radiator when the internal fans are on and the external fans are off, but it basically just gives it ambient room temperature performance. So I'll be going over some of the parts shortly. So the controller running the fans has an extended cable that goes into the back, powers with a Molex pin. I have a kill switch for the internal fans, which I'll turn off. So now we're just running on pump only. We have a pump inside, and we have a pump outside. It's all the same exact loop. It's just that due to the length of the hose and whatnot, and the drag that the 3 blocks create, I needed a second pump, so I added a second pump. So first, we'll be getting some ambient room temperature performance readings, and then we'll turn on the outdoor radiator and see how it performs. It's 45 degrees outside right now. Alright, so computer's on. Let's see, water temp's at 19 degrees Celsius. I'll turn on OSD. We'll go to benchmarks, applications, we'll run Heaven, full screen. Alright, so we'll give it about 5-10 minutes. It doesn't take it very long to hit maximum soak temp, which is usually for the GPU, it's about 44 degrees or so. The CPU isn't really taxed in this benchmark, so that number won't be that great. Do note this is a stock IHS CPU, so like it does get hot. It's not very efficient. I have a different direct die block that I'm going to be installing later once the DLID tool arrives. So let's give it a sec and see what the temps get to. Okay, so we've kind of settled on around 40 degrees Celsius with the CPU spiking to 60 degrees Celsius. CPU definitely needs that direct die block. So now I'm going to kill the internal fans. Those are off. Let me turn on the outdoor radiator. There we go. It's set at a very low profile, fan profile. Doesn't really seem to need that much airflow to work. So, and the main benefit is that it's always cycling ambient, well, I guess outdoor temperature. So it's never cycling its own heat, unlike a computer does. Even if you have a perfectly flowing airflow case, you're still heating up the air that the computer resides in. So that's the main benefit of the outdoor radiator. And alright, let's give it a few minutes and let's see what temps we drop to. Okay, so it's been running for about 4 minutes, and this is obviously an asymptote, so like it'll take basically infinitely long to get to a super low temp, mainly because it's been running, it's already heat soaked. But we dropped from roughly 40 degrees Celsius on the GPU down to 27 within a few minutes. Most of the cooling's done within like the first 2-3 minutes, and there's not much sound right now, but as you can see, I have the pumps set so that they're like running at the highest they can without generating an insane amount of sound. So they are running decent flow rate, and the flow rate definitely makes a difference because there's about 20 feet of hosing or so. So I used to just run the single. It's not a D5 pump, it's a DDC, so it's only 1,000 liters a minute, or an hour, sorry. And then I added this one, which has a D5 pump, so we're up to 2,500 liters per hour, and that definitely increased the cooling temperature. Long story short, we are at 26, 27 degrees, so we dropped 13 degrees Celsius, and let me just X out of that, and let's check the water temp. So the water temp's actually still pretty warm. It's 15 degrees. This gets down to roughly 2 degrees Celsius if it's around 30, 33 degrees outside. The outdoor radiator hasn't been running long enough for this to really drop massive temp. So yeah, there you have it. So that's 15 degrees Celsius with a running temp of 26. It's liquid metal on the GPU, so that's kind of why the temps are pretty good on that, and it's only a 330 watt card. Let's see what other tests we can do. I did want to add a note here. So I have my memory water cooled, I have the CPU and the GPU water cooled, and especially the memory block is quite restrictive, and that's kind of why I had to move to 2 pumps. And as far as the water cooling in the computer itself, there's no radiator at the bottom. There's a 360 millimeter regular thickness radiator at the top, and a bigger thickness 360 millimeter in the front, and it pulls air this direction, so it kind of heat soaks itself going to the second radiator. But yeah, we still only hit about 40 degrees Celsius, so it's a decent cooling system. But with this outdoor radiator setup, you could technically just build a whole computer without even needing radiators on the inside. And the only thing you really need to build the system is you solder up a wire that's a Molex power with a switch, and then you get an extension for your PWM wire, which plugs into the motherboard, and then you can control that fan speed with the motherboard. And then all you need other than that is quick disconnects. Now these aren't great, they still leak when you take them off, but basically if I'm going to a LAN party or something, I can disconnect these two, I can plug the computer into itself so that it's a completely separate loop, and then I can take it down to the workshop to work on or whatnot, and then you plug the radiator to itself, and that way it's a removable system. It's not just like locked in place. And I put the second pump outside because it makes it a lot easier to flush coolant and work on. But yeah, that's pretty much it. Let me know if you like more videos like this. So I was about to finish the video and upload it, but I just wanted to show the temps that it dropped down to. So it hit its asymptote. It's about 11 degrees Celsius, and outside temperature is 44 degrees, so that's the main reason why it's only hitting around 10 Celsius. But I'll run the test again just to show what a non-heat soaked temp would be, and see what it gets. Yeah, so just so that I can show how it's actually significantly cooler than previously in the video. But yeah, so we're at 23 degrees Celsius GPU temp. So it's a let's see, that's 17 degrees Celsius drop from 40 degrees Celsius. That's pretty good.